The emergency alarms screamed through every corridor of Station Refuge 7. Kate dropped her welding torch and ran toward the central command deck. She had been working in the lower maintenance bay when the first warnings hit. Now, 3 minutes later, every screen in the station flashed the same terrible message in a dozen alien languages. Critical system failure. Starcore drive offline. Kate pushed through a crowd of panicking refugees in the main corridor. Most of them were families, their blue skin pale with fear. They had fled here 2 days ago when their home-world's sun began its final collapse. Now they were trapped on a station that was falling toward a dying star. Commander stood at the main console in the command center. The tall's 4 arms moved across multiple displays at once. His face showed the kind of calm that came from years of military training, but Kate could see the tension in his shoulders. She had worked with enough alien species to read their body language. "How bad is it?" Kate asked as she reached the console. His primary eyes focused on her, while his secondary eyes continued monitoring the screens. "The Starcore drive suffered a quantum harmonizer fracture. We are falling into the star's gravity well. We have less than 3 hours before the station reaches critical heat levels." Kate felt her stomach drop. The Starcore drive was what kept the station stable in space. Without it, they were just a metal box being pulled toward a furnace that could melt planets. She looked at the sensor readings. 40,000 refugees were on this station, 40,000 people who had already lost their homes. "Can you fix it?" she asked. No, his voice was flat. "A quantum harmonizer requires molecular restructuring. We would need a forge facility. The nearest one is 3 weeks away at maximum speed." "What about bypass protocols?" "We tried. The fracture is too severe. The harmonizer is operating at 8% capacity. We need minimum 70% to escape the gravity well." Gestured to a group of engineers working frantically at another console. "My team has been attempting every standard solution for the past 40 minutes. Nothing works." Kate moved closer to look at the technical readouts. She had never worked on a Starcore drive before. Human stations used simpler systems, but she understood the basic principles. Energy flowed through the harmonizer to create a stable quantum field. That field pushed against local gravity to keep the station in position. With the harmonizer broken, the field was collapsing. A young engineer named looked up from his station. "Commander, the outer hull is beginning to show stress. Gravitational force is increasing." Secondary arms clenched into fists. Kate had learned that this meant he was controlling strong emotions. "Continue attempting bypass solutions. Try rerouting through the secondary power grid." "Already attempted, Commander. Insufficient capacity." Kate watched the engineering team work. They moved with precision and followed strict protocols. Each action was careful and measured. They checked readouts, consulted databases, and every decision through multiple systems. It was efficient. It was also too slow. "What if we cannibalize parts from the docked ships?" Kate suggested. "Some of them might have compatible components." Shook his head. "We checked. The civilian ships use different drive systems. Their components are not compatible with our Starcore specifications." "Not compatible or not rated for the same power levels?" "Both." Pulled up a schematic on the main display. "Look at the harmonizer. It operates at quantum energy levels that would destroy conventional components in microseconds. We cannot simply attach random parts and hope they function." Kate studied the schematic. The harmonizer was a beautiful piece of engineering. 12 resonance channels aligned in perfect quantum symmetry. The fracture had destroyed 9 of them. The remaining 3 were intact but couldn't carry enough power to save the station. She thought about the broken equipment she had fixed over the years. Mining rigs on Earth's moon, atmospheric processors on Mars, water recyclers in the asteroid belt. None of them were as advanced as this alien technology, but they all followed the same basic rules. Energy in, work done, energy out. The package changed, but the principles stayed the same. "Let me look at it," Kate said. Laughed. It was a sharp, clicking sound that they made when something amused them. You work on life support systems and waste recyclers." "I work on machines that need to keep running," Kate replied. "Same as this." "This is a quantum harmonizer," said slowly, as if explaining to a child. "It requires precise calibration and specialized tools. You humans use primitive Earth-grade equipment." Kate didn't argue. It was true. Her toolkit was sitting on a bench in the maintenance bay right now. Wrenches, hammers, wire cutters, welding gear, most of it was decades old. Her grandfather had used the same tools on Titan's mining colonies before Kate was born. Compared to the gleaming plasma calibrators and quantum wrenches the alien engineers carried, her equipment looked like museum pieces. Held up one hand for silence. "We do not have time for debate." He looked at Kate with all four eyes. "You believe you can repair the harmonizer?" "I don't know," Kate said honestly, "but I know I can try things your people won't." "Explain." "Your engineers are trained to maintain systems within specifications. When something breaks beyond repair parameters, you wait for replacement parts or proper facilities." Kate pointed at the schematic. "I was trained to fix things with whatever I have because replacement parts might never come." Different approach. Was quiet for a long moment. Kate could see him calculating odds. The station was falling toward the star. His trained engineers had exhausted every approved solution. She was offering something unapproved and probably impossible, but it was something. "You have 1 hour," said finally. "If you cannot restore the star core to functional capacity in 60 minutes, we will need that time to prepare evacuation shuttles. We cannot save everyone, but we might save some." Made a protesting noise. "Commander, giving her access to the star core chamber is dangerous. If she damages it further, we lose even the 8% capacity we have left. If we do nothing, 8% capacity is worthless. We will be dead in less than 3 hours." Entered a command into his console. "Kate is granted full access to Starcore Chamber 7. All safety protocols are suspended. She has complete authority to modify systems as needed." Kate felt the weight of what she had just accepted. 1 hour to fix something she had never seen before with tools designed for simpler work. 40,000 lives depending on whether she could make alien technology work through sheer stubbornness. She turned toward the door. "I need to get my tools." "Your tools?" Couldn't keep the disbelief from his voice. "What can Earth-grade tools possibly do that our equipment cannot?" Kate paused at the doorway. Hanging from her belt was her grandfather's wrench. It was old carbon steel, worn smooth in places from decades of use. Rust marked the edges despite her best efforts to maintain it. Her grandfather had used it to repair fusion reactors with parts that were never meant to work together. He had kept people alive in places where giving up meant freezing to death in the dark. "Maybe nothing," Kate admitted, "but it's what I have, and what I have has kept me alive this long." She left the command center at a run. Behind her, she heard speaking to in rapid. She didn't need to understand the language to know he was saying this was hopeless. Maybe he was right, but Kate had learned a long time ago that hopeless just meant nobody had tried the wrong solution yet. The Starcore chamber was deep in the station's center. Kate grabbed her toolkit from the maintenance bay and made her way through corridors filled with frightened refugees. A human child, maybe 5 years old, was crying in her mother's arms. The mother looked at Kate with desperate Kate spent the first 10 minutes just watching the harmonizer. She didn't touch anything. She didn't check readouts or consult technical manuals. She just observed how the energy moved through the damaged system. The alien engineers would have called this a waste of time. They had sophisticated scanners that could map every quantum fluctuation in microseconds. But Kate had learned from her grandfather that scanners only told you what was happening. They didn't tell you why. For that, you needed to listen. She moved around the harmonizer slowly, placing her hands on different parts of the housing. The vibrations changed depending on where she touched. Near the fracture, the metal buzzed with chaotic energy. Farther away, the pulse was steadier but weaker. 3 of the 12 resonance channels were still working. She could feel them humming with power under her palm. The door to the chamber opened, stepped inside carrying a data tablet. "Commander has ordered me to monitor your progress. He wants regular updates." "Fine, tell him I'm thinking." "You have been here for 10 minutes. You have not made any adjustments." "I'm figuring out what the machine is trying to tell me." Kate moved to another section of the housing and pressed her ear against the metal. She could hear the energy flow like water through pipes, smooth in some places, turbulent in others. Watched her with obvious confusion. "Our diagnostic systems have already mapped the entire failure cascade. We know exactly which channels are damaged and what power levels we are receiving. What more is there to understand?" "Those scans tell you what's broken. I need to know what's still working and how hard I can push it." "The specifications are clear. Each resonance channel operates at specific quantum frequencies. Exceeding those frequencies will cause permanent damage." Kate pulled her head away from the housing. How long have you been an engineer? I completed my training 2 years ago. I graduated in the top 5% of my class. So you learned everything by the book. Follow procedures, respect specifications, maintain systems within approved parameters. That is how engineering works. That's how engineering works when everything is perfect. Kate opened her toolkit and pulled out her grandfather's wrench. I learned engineering from a man who kept fusion reactors running on Titan with parts scavenged from 50-year-old mining equipment. He taught me that specifications are guidelines written by people who never imagined the situation you're actually in. Looked at the wrench in her hand. That tool is corroded. The metal has surface degradation. It should have been replaced decades ago. Probably, but it still works. Kate turned back to the harmonizer. The problem with your diagnostic scans is that they're absolute. They say a channel is working or it's not, but that's not how machines actually behave. There's a whole range between perfect function and complete failure. That's where I work. She started pulling components from unlikely places in her toolkit. A magnetic coil from a portable generator, copper wire she had been using to repair a water filter, a heat sink from a broken environmental control unit. His eyes widened as he realized what she was doing. You cannot attach random components to a quantum harmonizer. Those parts are not rated for this energy level. They will fail instantly. Maybe they'll work long enough to get us out of this gravity well. Kate examined the fracture closely. See this crack? It's not complete. There's still some structural integrity. And these 3 working channels, they're not just functional, they're stable. The diagnostic probably flagged them as insufficient, but that doesn't mean they're weak. It means they're outnumbered. She began disassembling parts of the harmonizer's outer housing. Her wrench, despite its rust and age, fit the alien bolts perfectly. The wear on its edges actually helped, giving her better grip on the smooth metal. What are you doing? His voice rose with alarm. Those housing sections protect the internal components from interference. They also restrict access. I need to reach the power flow channels directly. That violates containment protocols. Good thing we suspended safety protocols then. Kate pulled away a housing panel and set it aside carefully. Beneath it, glowing conduits carried energy into the harmonizer's core. She could see the 3 working channels pulsing with blue light. The 9 dead channels sat dark and cold. Kate studied the layout for a long moment. Energy flowed in from the station's main reactor through a primary feed. The harmonizer split that energy across 12 channels, synchronized them at quantum level, and output a unified field. With 9 channels dead, the field was too weak. The obvious solution was to repair the dead channels, but that was impossible without specialized equipment. I need a plasma coupler rated for about 6,000 watts, Kate said. Checked his tablet. The parts inventory does not have spare couplers. All available units are currently in use maintaining critical systems. Then I'll make one. Kate walked to a corner of the chamber where a beverage dispenser sat mounted on the wall. She pulled open the access panel and began removing components. That is a coffee dispenser, said flatly. That is a machine that heats liquid to precise temperatures using controlled plasma energy. The coupler inside is rated for about 7,000 watts. Kate worked quickly, disconnecting the unit and pulling out the plasma assembly. It's not designed for quantum energy, but energy is energy. The frequencies are different, but the basic principle is the same. Move power from point A to point B without loss. The coupler will not interface with the harmonizer's power grid. The connection ports are completely different. Kate pulled out her wire cutters and some copper wire. That's what improvisation is for. She began rebuilding the connection system. The plasma coupler from the coffee maker was too small to handle the harmonizer's full power load, but it didn't need to. Kate was building a bypass system. Instead of trying to fix the 9 dead channels, she would route power around them. The 3 working channels would carry their normal load. Her bypass would carry an additional load. Together, they might produce enough output. Watched in silence as Kate stripped wire, bent metal contacts, and physically connected components that were never meant to work together. His training told him this should be impossible. Every engineering principle he had learned said you couldn't just mix random parts and expect functional results. But his eyes showed him Kate doing exactly that with confident, practiced movements. "Where did you learn to do this?" he asked quietly. Earth. Kate twisted 2 wires together and checked the connection strength with a sharp tug. Humanity's home world taught us to be good at improvising. I have read about Earth. It is classified as a high-gravity death world with extreme environmental variation. Few species could survive there naturally. Exactly. Earth doesn't care about your specifications. Equipment fails constantly because conditions are always changing. Temperature swings, humidity, atmospheric pressure, gravity stress, you name it. Human engineers learned fast that perfect maintenance is impossible. You either learn to fix things with whatever you have or you die. Kate pulled a maintenance bot apart and stripped the magnetic shielding from its power core. She began wrapping this shielding around her improvised bypass assembly. Realized she was creating heat protection. The makeshift coupler would run hot, possibly hot enough to damage surrounding systems. The shielding would contain that heat. "But how do you know it will work?" asked. "Without testing, without calculations, how can you be certain?" "I can't be certain, but I can make a good guess based on experience." Kate positioned her bypass assembly near the harmonizer's power input. "See, your people design systems to work perfectly because you come from stable worlds. When something is designed to work perfectly, it only works perfectly. Any deviation from ideal conditions causes failure." She used her wrench to bend a mounting bracket into a new shape, creating a holder for her bypass. Humans design for imperfection. Our equipment is built to handle stress, variation, and partial failure. That makes it less efficient in ideal conditions, but more reliable when everything goes wrong. Kate connected the bypass to the main power feed using a junction she fabricated from scrap metal and wire. It looked crude compared to the elegant alien technology surrounding it, but the connections were solid. She had learned to make strong joins in her grandfather's workshop before she was 10 years old. "This will route approximately 30% of additional power into the system," Kate explained. "Your 3 working channels are currently carrying about 8% of total capacity. With my bypass, we'll hit maybe 40%. Still not enough." "Then what is the purpose?" "Step 1, I'm not done yet." Kate moved back to examine the 3 working resonance channels. "These channels are still functional, which means they can handle more load. The question is how much more." She placed her hand on the housing above the channels and felt the vibration pattern, steady and strong. The channels weren't struggling with their current load. They had capacity left. "The diagnostics rated each channel for a specific power level," said, checking his tablet. "Exceeding that level risks permanent damage. Those ratings assume the channels are part of a complete 12-channel system, but they're not anymore. The power dynamics have changed." Kate pulled out a set of fine tools and began making precise adjustments to the channel calibration ports. "If I optimize these 3 channels to run at higher efficiency, they can carry more load without exceeding their actual physical limits." "You are adjusting quantum resonance frequencies without a calibrator." "I'm adjusting them by feel." Kate made a tiny turn with a thin probe. The vibration under her hand changed slightly. She turned the probe back a fraction and the vibration smoothed out. "There. That channel is now running at about 160% of its rated capacity." Stared at his tablet. "The readings confirm. How did you do that without measurements?" "I listened to what the machine was telling me." Kate moved to the next channel and began the same process. "Machines talk, not with words but with sound and vibration and heat. When something is working right, it feels right. When it's about to fail, it tells you." She finished optimizing all 3 channels. They were now running hot but stable, each carrying almost double their designed load. Combined with her bypass, the system might reach 55% capacity, still short of the 70% minimum needed to escape the gravity well. Kate stepped back and looked at her work. The modified harmonizer looked like a disaster. Improvised components held together with wire and determination. Housing panels removed to expose delicate systems. 3 channels glowing bright with excess power. It should not work. By every rule of proper engineering, it was a failure waiting to happen. But Kate had learned that proper engineering was a luxury you only had when you had proper resources. Right now, they had a broken harmonizer, limited time, and 1 human engineer who refused to accept that impossible meant impossible. 42 minutes remaining," said softly. Kate nodded. She had made progress, but it wasn't enough. She needed to find another 15% power output somewhere. She looked at the fracture in the harmonizer's core and noticed something she had missed before. The crack wasn't just breaking the structure. It was leaking energy. Small amounts of quantum power escaped through the damaged area and dispersed into the chamber. Kate grabbed 3 magnetic containment rings from her toolkit. She had pulled them from a waste recycling unit months ago, thinking they might be useful someday. They were designed to contain and redirect small amounts of energy in recycling processes. Nothing compared to the power levels in a StarCore harmonizer, but Kate wasn't trying to contain full power. She just wanted to catch what was leaking. She positioned the first ring near the fracture where quantum energy was escaping. The ring hummed as it activated, its magnetic field grabbing the loose energy. Kate adjusted the angle carefully, watching how the leaked energy flowed. It reminded her of water dripping from a cracked pipe. You couldn't stop the leak without the right tools, but you could catch the water and use it. "You are attempting to recapture the quantum bleed," said, understanding dawning in his voice. "But those rings cannot channel quantum energy back into the harmonizer. They lack the proper interfaces." "They don't need to channel it back into the harmonizer." Kate positioned the second and third rings to form a triangular collection field. "They just need to hold it long enough for me to redirect it somewhere useful." She pulled the shielding from the maintenance bot and wrapped it around the 3 rings, creating a crude containment chamber. Then she connected the assembly to her improvised bypass using stripped wire and metal contacts bent into shape with her wrench. The whole thing looked like something a child might build from scrap, but the energy readings on her portable meter showed it was working. The leaked quantum energy, instead of dispersing uselessly into the chamber, was now being caught and fed into her bypass system. It wasn't much, maybe 5% additional recovery, but 5% might make the difference between dying and surviving. 34 minutes, announced. His voice had changed. He wasn't mocking her anymore. He was watching someone do something he didn't understand, and his scientific training made him curious despite his fear. Kate checked her work. The bypass was carrying power. The 3 optimized channels were running hot but stable. The energy recapture from the leak was feeding additional power into the system. Her portable meter showed total output at about 58% of minimum required capacity. Not enough. She needed 12 more percent, 12% to reach the 70% threshold that would let them escape the star's gravity well. She had already pushed every component beyond its safe limits. The bypass was running at temperatures that should melt the connections. The 3 channels were carrying loads that should crack them. The energy recapture system was holding power levels it was never designed for. Kate walked slowly around the harmonizer, thinking. Her grandfather used to say that the answer to an impossible problem was usually hiding in something you had already dismissed as irrelevant. She reviewed everything she knew about the system. The harmonizer took energy from the reactor and split it across 12 channels. Those channels synchronized at quantum level to create a unified field. That field pushed against local gravity. With only 3 channels working plus her improvised bypass, the field was too weak. She couldn't fix the 9 dead channels without a molecular forge. She couldn't make the 3 working channels carry more power without breaking them. She couldn't improve her bypass without better components. But maybe she didn't need to add more power. Maybe she needed to use the power they had more efficiently. "Show me the field output specifications." He pulled up the data on his tablet. The harmonizer produces a spherical quantum field with even distribution in all directions. This provides stable positioning in 3-dimensional space. Kate studied the numbers. A spherical field made sense for a station that needed to maintain position against gravity pulling from multiple angles. But right now, they weren't trying to maintain position. They were trying to escape in one specific direction, up and away from the star. "What if we don't need a sphere?" Kate said slowly. "What if we just need to push in one direction?" Looked confused. The harmonizer is designed for spherical output. You cannot simply change the field shape without recalibrating the quantum matrices. "Can't or shouldn't?" "Both. The calibration requires precise adjustments to quantum phase alignment. It would take hours even with proper equipment." Kate picked up her wrench and approached the harmonizer's output regulator. "Or I could just physically redirect the energy flow." "That is not how quantum fields work. Energy is energy. It goes where you point it." Kate began removing the field distributor assembly. This was the component that took the unified field and spread it evenly in all directions. It was elegant engineering, maintaining perfect balance. Kate didn't need perfect balance. She needed every bit of power pushing them away from the star. She examined the distributor. Multiple output ports arranged in a geodesic pattern, each one directing field energy in a different direction. Kate started closing off ports. She bent metal covers over them using her wrench, physically blocking the energy from flowing through. It was crude and violent, but it worked. Field energy that would have been wasted pushing sideways or downward was now forced to redirect. Watched in horror. You are destroying the distributor's symmetry. The field will become unstable. Good, stable means predictable. We don't need predictable right now. We need powerful. Kate closed off 7 of the 12 ports, leaving only the 5 that pointed up and away from the star. The harmonizer is still producing the same total field strength, but now all that strength is pushing in the direction we want to go. She reconnected the modified distributor and checked her meter. The effective field strength in the escape direction had jumped to 68%. Close, so close she could taste it, but still 2% short of minimum. Kate looked at the harmonizer with frustration. She had rebuilt it with scrap parts and determination. She had optimized every component beyond safe limits. She had redirected energy flow in ways that violated design principles, and she was still 2% short. 27 minutes, said quietly. Kate's hands were shaking slightly, not from fear, though fear was there, from exhaustion. She had been working non-stop in a hot chamber, making constant micro-adjustments and fabricating components on the fly. Her shoulders ached. Her fingers were cramping. Her grandfather's wrench felt heavy in her hand. She thought about the 40,000 people on this station, families who had fled their dying world, children who didn't understand why they couldn't go home, parents who were trying to be strong while their world collapsed. They were all depending on a human engineer with a rusty wrench to save them. 2%. She needed 2% more power. There had to be something she was missing, some component she could optimize further, some energy loss she could recover, some efficiency she could improve. Her eyes fell on the power feed coming from the station's main reactor. Energy flowed through a standard conduit rated for the harmonizer's full load. But the harmonizer wasn't running at full load anymore. It was running at 68%. The conduit was bigger than necessary, which meant power was flowing through it slower than it could. "What's the power feed's transmission loss?" Kate asked. Checked his tablet. 2.3%. That is within acceptable parameters for this conduit type. 2.3%. Energy lost as heat during transmission from the reactor to the harmonizer. Normally insignificant. Right now, it was the exact amount she needed. Kate examined the conduit. It was standard galactic design built for reliability and safety. The energy moved through it at controlled speed with multiple safety buffers to prevent overload. Those safety buffers created resistance. Resistance created loss. She grabbed her wire cutters and began stripping the conduit's outer safety sheathing. Made a choking sound. That sheathing protects against power surges and electromagnetic interference. It also creates resistance that slows energy transmission. Kate exposed the inner conductor and found the flow regulators, small devices that maintained steady power delivery regardless of demand fluctuations. They were good engineering for normal operations. Right now, they were throttles holding back power she desperately needed. Kate started removing the regulators. Each one she pulled out reduced safety and increased instability, but it also reduced resistance. Power flowed faster through the conduit without the regulators fighting to maintain steady flow. Her meter showed transmission loss dropping, 2.1%, 1.8%, 1.4%. If there is a power surge from the reactor, the harmonizer will receive unregulated energy, warned. It could cause catastrophic overload. If we don't get that extra power, we're dead anyway. I'll take the risk. Kate removed the last regulator. Transmission loss dropped to 0.9%. She had recovered 1.4% of power that was being lost to safety systems. Still 0.6% short. Kate looked around the chamber desperately. Every component was already pushed beyond limits. Every efficiency was maximized. Every trick she knew had been used. 0.6% wasn't much, but it might as well be a mile when you were 0.6% away from survival. Her eyes landed on the environmental controls for the Starcore chamber. The room was kept at precise temperature and humidity to protect sensitive equipment. Climate control that ran constantly, drawing power from the station's grid. Not much power, but some. Can you shut down environmental controls for this chamber? For what purpose? Every system on this station pulls power from the reactor. If we temporarily shut down non-critical systems, that power becomes available for the harmonizer. The environmental controls are not connected to the harmonizer's power feed. No, but they draw from the same reactor. If the reactor has less load from other systems, it can supply more power to the harmonizer. Kate was already moving toward the environmental control panel. How much power does climate control use in this chamber? Checked his tablet. 0.4% of total station power. Not enough. Kate needed 0.6%, but it was a start. What else can we shut down without killing people? Kate asked. Scrolled through system lists. Non-essential lighting in cargo sections, recreational facilities, secondary computer systems. Combined, they might provide another 0.3%. 0.7% total. Enough. Kate opened a communication link to the command center. Commander, I need you to shut down all non-essential systems and route their power to the main reactor. His voice came back immediately. Explain. I'm 0.6% short of minimum escape power. If you can free up 0.6% of station power by shutting down other systems, the reactor can feed it to the harmonizer. There was a pause. Kate could imagine calculating the request. Shutting down systems throughout the station would cause panic. People would think the station was dying. But he was a military commander. He understood necessary sacrifices. Implementing now, said. Throughout the station, lights dimmed. Recreational areas went dark. Secondary computers powered down. Climate control in non-critical areas stopped. Thousands of small systems that made life comfortable ceased operating. Every watt of power they had been using flowed back to the reactor. Kate watched her meter as the reactor's available output increased. The harmonizer, sensing additional power in the main feed, drew more current. The output reading climbed. 69%, 69.4%, 69.8%. 70.1%. Minimum threshold achieved. 19 minutes remaining, said. His voice shook slightly. You did it. Kate didn't celebrate. 70% was minimum to escape the gravity well. It wasn't enough to escape quickly or safely. It was barely enough to avoid falling into the star. They needed to engage the drive now and hope everything held together long enough to get clear. Commander, the harmonizer is ready, Kate said into the comm. But you need to know this is not a stable repair. Every component is running beyond safe limits. I don't know how long it will last. How long do we need it to last? Asked. To reach minimum safe distance from the star. About 30 minutes of continuous operation. Another pause, and your assessment of whether it will last that long. Kate looked at her improvised bypass held together with wire and scrap metal. She looked at the 3 resonance channels glowing bright with excess power. She looked at the modified distributor forcing all energy in one direction. She looked at the exposed power conduit without its safety regulators. Honestly, Commander, I have no idea, but it's what we have. The harmonizer's scream was not a sound any machine should make. It was metal under impossible stress, energy flowing through channels never meant to carry such loads, improvised components holding together through determination and physics. Kate felt the vibration through the support rail she was gripping. The entire chamber shook. The station lurched. Kate's stomach dropped as gravity shifted. They were moving, actually moving. The Starcore drive was pushing them up and away from the dying star's gravity well, slowly but definitely. Station is ascending, his voice came through the comm. Current velocity is below optimal but increasing. All decks report secure. Kate watched her portable meter. Power output was holding at 70.1%. The 3 optimized channels glowed so bright they hurt to look at directly. Her improvised bypass was cooking, surrounded by a haze of heat. The magnetic containment rings capturing leaked energy were vibrating with the strain, but everything was holding. 15 minutes to minimum safe distance, announced. 15 minutes. Kate needed her repairs to last 15 minutes. Every second that passed was a second closer to survival. The harmonizer continued its awful scream. She could see stress fractures forming in the housing around the 3 working channels, tiny cracks spreading through metal that was never designed to handle this much power for this long. Temperature in Channel 2 is rising, reported, watching his tablet. It has exceeded maximum safe operating level. Kate had expected this. Running the channels at double their rated capacity generated heat. Lots of heat. The cooling systems built into the harmonizer were designed for normal operations, not emergency overload. She moved to the channel and placed her hand near the housing. The heat was intense but not immediately dangerous. "How much over maximum?" Kate asked. 23% over maximum safe temperature. "Can the channel handle it?" "Unknown. We have no data for operation at this temperature level." Kate felt the vibration through the housing. The channel was still running smooth despite the heat. The rhythm was fast and hard but steady, like a runner pushing beyond their normal pace but still in control. The question was how long they could maintain that sprint. "Channel 2 is stable for now," Kate said. "Monitor it, but don't shut it down unless temperature goes critical." The station shook again. Kate grabbed the support rail as the floor tilted. Through the chamber walls, she could hear groaning metal. The station's structure was feeling stress from acceleration and residual gravitational pull. They were fighting their way out of the star's grip. "Hull stress increasing in sections 4 and 7, reported. "Emergency force fields are compensating." Kate checked her meter. Power output was steady. 70.1%, not dropping but not rising either. They had just enough power to escape slowly. Any loss of capacity would stop their ascent. They would hang in space for a moment, fighting against gravity, and then start falling back toward the star. 12 minutes to safe distance, said. Kate's improvised bypass chose that moment to start failing. She saw it on the meter first. A tiny drop in power, 70%, then 69.9%. She looked at the bypass assembly and saw smoke rising from the plasma coupler she had taken from the coffee maker. "The bypass is overheating," said urgently. "The plasma coupler is melting." Kate grabbed her wrench and moved to the bypass. She could see the problem. The coupler was designed to handle 7,000 watts for short bursts to heat coffee. She was pushing almost constant high-wattage power through it. The metal housing was starting to deform from the heat. She couldn't let it fail completely. If the bypass died, they would drop to about 58% power, not enough to maintain their current escape velocity. They would slow down, stop, and then fall. Kate began making adjustments. She loosened connections slightly to reduce resistance. She repositioned the magnetic shielding to direct heat away from critical components. She used her wrench to gently tap the housing, redistributing stress points. It was like trying to keep a dying engine running for just a few more miles. "Power output stabilizing at 69.7%, reported. Not good, they had lost 0.4%. Kate tightened a connection and the output climbed to 69.9%. Close enough. The bypass was dying, but dying slowly. She just needed it to die slowly enough. 10 minutes to safe distance. The voice was tight with tension. Kate moved back to the 3 resonance channels. Channel 2 was glowing brighter than the others, running hotter. She could see stress cracks spreading through its housing faster now. The metal was beginning to fail under sustained overload, but it was still working, still carrying power, still pushing them away from the star. She placed her hand on the housing above Channel 2 and felt the rhythm of energy flow. It was starting to stutter, small gaps in the smooth pulse, like a heartbeat with occasional skips. The channel was approaching its limit. "Channel 2 temperature is now 30% over maximum safe level," said. "Structural integrity is compromised." "How long before failure?" Checked his calculations. "Unknown. The channel is operating in conditions we have no data for. It could fail in 10 seconds or 10 minutes. Kate looked at the meter. 69.9% output. They needed every bit of that to maintain escape velocity. If Channel 2 failed, they would drop to about 45%. They would stop ascending immediately and fall back into the star. "Can you boost power to Channels 1 and 3 to compensate if Channel 2 fails?" Kate asked. "Negative. They are already operating at maximum safe capacity. Additional load would cause them to fail as well." So if Channel 2 died, they all died. Kate understood. She moved to Channel 2 and began making micro-adjustments to its calibration. Small tweaks to optimize energy flow, reduce friction, minimize the heat being generated. It was like trying to cool a fire by rearranging the wood. It might help a little, but the fire was still burning. The station shook violently. Emergency alarms blared through the comm system. Kate grabbed the support rail to keep from falling. "Gravitational stress spike," reported. "The star's outer layers are beginning to collapse. Gravitational fluctuations are increasing." Kate felt her blood run cold. A collapsing star didn't pull steadily. It pulled in waves as material fell into its core and released energy. Each wave would create a gravitational surge. If those surges were strong enough, they could overcome the harmonizer's output and pull the station back down. 8 minutes to safe distance, said. We need to maintain current velocity through the gravitational fluctuations. Kate looked at her jury-rigged harmonizer. It was already at its limit. There was nothing left to optimize, nothing left to push harder. If gravitational pull increased, they would need more power, and they had no more power to give. Another shudder ran through the station. Kate's meter flickered. Power output dropped to 69.6%. They were slowing down. Another gravitational wave incoming, warned. Estimate 30 seconds. Kate made a decision. She moved to the power conduit where she had removed the flow regulators. Without those regulators, power transmission was direct but unstable. Small fluctuations in reactor output caused immediate fluctuations in harmonizer power. That was dangerous during steady operations, but if she could time it right, she might be able to use it. Commander, I need you to surge reactor output during the next gravitational wave. Explain quickly. The reactor can produce short bursts above steady output. Usually the flow regulators smooth out those bursts to protect equipment. I removed the regulators. If you surge the reactor when the gravity wave hits, I can push extra power through the harmonizer for a few seconds, enough to fight through the wave. And if the harmonizer receives too much power during the surge, it might explode, but if we don't surge power, the gravity wave will pull us back down anyway. Silence on the comm. Kate could imagine weighing options, death by explosion or death by gravity, not much of a choice. Prepare for reactor surge in 20 seconds, said. Kate moved back to the harmonizer and placed her hands on the housing. She needed to feel the power flow in real time. When the surge came, she would have to make instant adjustments to prevent catastrophic overload. Channel 2 was already at its limit. If it received too much power too fast, it would crack completely. 15 seconds to gravitational wave, counted down. 10 seconds, 5 seconds. Kate felt the wave before the sensors registered it. A pull against her body, like standing at the edge of a cliff and feeling the wind try to drag you over. The station groaned. Metal stressed. Alarms screamed. Reactor surge now, commanded. Power flooded through the conduit. Kate's meter spiked. 72%, 75%, 78%. Too much. Channel 2's housing cracked audibly. Kate grabbed her wrench and slammed it against the distributor assembly, physically redirecting some of the excess power away from the damaged channel. The gravitational wave hit full force. Kate felt herself pressed against the floor as gravity pulled down harder. The station's ascent stopped. For a horrible moment, they hung motionless in space, drive pushing up while gravity pulled down. Then the surge power from the reactor tipped the balance. The harmonizer screamed louder than ever, pushing against the wave with everything it had. The station shuddered and resumed its climb. Slowly, painfully, but climbing. Wave passing, said. 6 minutes to safe distance. Kate's meter showed power dropping back down as the reactor surge ended. 76%, 73%, 70%. Back to normal. But Channel 2's housing now had a crack running halfway around its circumference. She could see light leaking through the crack, quantum energy escaping into the chamber. Channel 2 has suffered structural failure, said, his voice shaking. It is still operating, but the housing is fractured. I can see that. Kate examined the crack. It was bad, but not immediately fatal. Energy was leaking, but the channel was still carrying load, for now. Another gravitational wave hit without warning. The station jerked downward. Kate was thrown against the wall. Her wrench flew from her hand and clattered across the floor. The lights in the chamber flickered. Emergency wave, no time to surge reactor, shouted. Brace for impact. Kate scrambled across the tilting floor and grabbed her wrench. The harmonizer's scream changed pitch, becoming a shriek of protest as gravitational force increased. Power output was dropping, 68%, 67%. They were being pulled back down. She reached the distributor assembly and saw the problem. One of the ports she had closed with bent metal was shaking loose from the vibration. Power was starting to leak through it sideways instead of pushing up. She grabbed the port cover and tried to force it closed again, but her hands slipped on the hot metal. Losing altitude, reported. We are descending back toward the star. Kate wrapped her hand in her shirt and grabbed the port cover again. She slammed her wrench against it, bending the metal closed. The impact sent pain shooting through her wrist, but the port sealed. Power redirected upward. The meter climbed, 68%, 69%. The station's descent slowed, stopped, and reversed. They were climbing again. 4 minutes to safe distance, said. Kate's hands were shaking. Her wrist throbbed where she had injured it, hammering the port closed. Channel 2 was visibly deteriorating, the crack in its housing spreading wider. The bypass was smoking badly, the plasma coupler barely holding together, but they were still moving up, still escaping. Another gravitational wave. This time Kate was ready. She braced herself against the support rail and kept her wrench in hand. The wave hit. The station shuddered. Power output dropped to 67%. Kate watched Channel 2 carefully, ready to make adjustments. The channel's housing cracked further. Light blazed through multiple fractures, but somehow, impossibly, the channel kept running. Kate could feel it through the vibrations in the floor. Channel 2 was dying, but it was dying fighting. 2 minutes to safe distance, said. The bypass's plasma coupler finally gave up. Kate watched it melt through completely, connections failing, power cutting out. The meter dropped, 65%, 63%, 60%. Not enough, they were losing speed. We are slowing, reported. Velocity is insufficient to reach safe distance. Kate looked at Channel 2. It was running at temperatures that should have destroyed it minutes ago. The housing was cracked in 6 places, energy leaking from every crack, but it was still carrying power, still functioning. She moved to the channel and placed both hands on the housing despite the heat. She could feel it dying. The vibration was rough now, stuttering badly, but there was still strength there. Channel 2 had more to give. She just needed to ask for it. Kate began removing the calibration limiters she had installed earlier. These were safety stops that prevented the channel from exceeding its optimized load. Without them, the channel could try to carry even more power. It would also fail much faster. "What are you doing?" asked. Asking Channel 2 for everything it has left. She removed the last limiter. Channel 2 responded immediately, drawing more power from the reactor. The housing glowed white-hot. New cracks formed and spread. But the power output climbed, 61%, 63%, 65%. 1 minute to safe distance, said. Channel 2 was dying. Kate could see it, feel it, hear it in the changing pitch of the harmonizer's scream. The channel was giving everything, burning itself out to push them those last few meters to safety. She kept her hands on the housing, making constant tiny adjustments, trying to hold it together for just a few more seconds. 30 seconds, Channel 2's glow intensified. The housing metal was starting to melt. 20 seconds, molten metal dripped from the cracks. The channel's energy output fluctuated wildly. 10 seconds, the housing collapsed completely. Channel 2 failed in a cascade of breaking metal and escaping energy. Power output plunged, 58%, 55%, 50%. The station's ascent stopped. For one eternal second, Kate thought they had failed. They were going to hang here just short of safety and then fall back into the star. Then's voice came through the calm and certain. "Station has reached minimum safe distance. Engaging emergency thrusters to push us further out. We are clear of the gravity well." Kate slumped against the wall, her legs suddenly unable to hold her weight. They had made it. Barely, impossibly, they had made it. Channel 2 had held together just long enough. 1 minute longer and it would have failed before they reached safety. 1 minute longer and they all would have died. The harmonizer, what was left of it, powered down. The remaining 2 channels stopped glowing. The ruined bypass smoked quietly in the corner. The whole assembly looked like it had been through a war, because it had. Was staring at the wreckage with an expression Kate couldn't read. Shock, maybe, or awe, possibly both. "You did it," he said quietly. "With improper tools and impossible modifications and no regard for specifications, you saved 40,000 lives." Kate picked up her grandfather's wrench from where it had fallen. The metal was scorched from the heat and the rust was burned black in places, but it was still solid, still functional, still doing its job. Kate sat in the station's observation deck 3 hours after the escape. Her wrist was bandaged where she had injured it, hammering the port closed. Her hands were covered in burns from touching hot metal. She was exhausted to her bones, but she was alive. 40,000 people were alive. That was enough. Through the viewport, she could see the dying star. They were far enough away now that it looked small and distant. Safe. Rescue ships were arriving, massive coalition vessels that would transfer the refugees to proper stations with functioning equipment. The emergency was over. Commander found her there. He moved quietly for such a large being, his 4 arms folded in a gesture Kate had learned meant respect. "I have filed my report with Coalition Command," said. "They are sending engineering teams to examine your work." "There's not much left to examine. Most of it burned out during the escape. They want to understand how it was possible. By all calculations, the harmonizer should have failed immediately when you exceeded safety parameters. Yet it functioned long enough to save everyone aboard." Kate shrugged. "Sometimes machines surprise you. They hold together when they shouldn't. They give you just a little more than you think they have." Sat down beside her. It was unusual. Commanders didn't typically sit with lower-ranked personnel. But Kate supposed that saving 40,000 lives changed normal protocols. "I have been an engineer for 30 years, said. "I have worked on the most advanced systems in the Coalition. I have always believed that proper engineering meant precise calculations, exact specifications, and controlled conditions. Watching you work challenged everything I know. Different approaches for different situations. Your way works great when everything is going right. And your way works when everything is going wrong. That's what Earth teaches you. Things go wrong all the time. You either adapt or you die." A group of Coalition engineers entered the observation deck. They were carrying data tablets and scanning equipment. Kate recognized the lead engineer, an older female from a species called the... She had 4 eyes and skin like polished stone. Administrator. "Engineer," said formally, "I need to interview you about your repair of the Starcore drive." Kate gestured to the empty seats. "Ask whatever you want." Sat down and activated her data tablet. The other engineers gathered around, all watching Kate with curious expressions. She felt like a specimen under examination. "I have reviewed the sensor logs from the Starcore chamber," began. "Your modifications violated 17 fundamental principles of quantum engineering. Can you explain your reasoning?" "I didn't know I was violating principles. I just fixed what was broken with what I had available." "But you used components that are not rated for quantum energy loads. The plasma coupler from the beverage dispenser, for example. That component is designed for household power levels. It was designed to move energy from point A to point B. That's what I needed. The energy levels were different, but the basic function was the same." Made notes on her tablet. "And the magnetic containment rings from the waste recycler. You used them to capture quantum bleed. How did you know they would not fail instantly?" "I didn't know for sure, but magnetic containment is magnetic containment. The rings were designed to handle energy fields in the recycler. I just redirected what kind of energy they were handling." Another engineer, a young male with green skin, spoke up. "But without proper calculations, you could not have known the stress levels. How did you determine safe operating parameters?" "I felt them." Kate saw their confused expressions. "I know that sounds strange, but machines tell you what they're doing if you pay attention. Vibration, heat, sound. When a component is about to fail, it changes behavior. You can feel that change." "That is not scientific," the green-skinned engineer said. "You cannot measure stress by feeling vibrations." "Can't I? I learned to maintain fusion reactors when I was 15. My grandfather taught me to place my hand on the housing and feel the power flow. If the vibration was smooth, the reactor was healthy. If it stuttered or knocked, something was wrong. After a few years, I could diagnose most problems without even looking at sensor readings." Leaned forward. "This is the problem we face. Your methods work, but they cannot be taught through standard training. How do we replicate what you did?" Kate thought about that. It was a fair question. She had saved the station, but only because she happened to be there with the right background. What happened next time when a different crisis hit a different station with different engineers? "Maybe you can't replicate exactly what I did," Kate said slowly. "But you can teach the thinking behind it. The Coalition trains engineers to maintain perfection. That's good for normal operations. But you also need engineers who can work with imperfection, who can see partial solutions instead of only complete failures." "How do we teach that?" "By making them work with broken systems and limited tools. by putting them in situations where the standard solution is impossible and they have to improvise, by showing them that specifications are guidelines, not laws of physics. One of the other engineers spoke up. That sounds dangerous. Ignoring specifications leads to equipment failure. Following specifications, too, strictly also leads to failure when you don't have the right equipment or enough time. You need both kinds of engineers. The ones who maintain systems perfectly when conditions allow, and the ones who keep systems running when conditions are terrible. Made more notes. Kate could see she was thinking hard about something. Finally, the administrator looked up from her tablet. I want to propose something to you, engineer. The Coalition has engineering training facilities on 17 worlds. We teach thousands of students every year. But we only teach one approach, precision engineering for optimal conditions. I want you to develop a new training program, emergency engineering for suboptimal conditions. Kate blinked. You want me to teach? I want you to create a program that teaches engineers to think like you do. Not to replace standard training, but to supplement it. So we have engineers who can handle situations like today. I don't have formal teaching credentials. You have something better. You have the experience of making impossible repairs work. That is what we need. Kate looked at her grandfather's wrench, still hanging from her belt. It was battered and scorched now, but it had done its job. She thought about her grandfather and the lessons he had taught her in maintenance bays and reactor rooms. Those lessons had saved 40,000 lives today. Maybe they could save more. I'll do it, Kate said, but I have conditions. Name them. No sterile classrooms. Students work with actual damaged equipment in realistic conditions. Time limits, limited tools, partial information. They need to feel the pressure. Agreed. And they work with human-grade tools, not advanced Coalition equipment. They need to learn that fancy tools don't make you a better engineer. Understanding makes you a better engineer. Hesitated. That will be difficult to explain to students who are used to the best equipment. That's the point. They need to learn that best equipment is a luxury. When you don't have it, you work with what you do have. Very well. I will arrange for the first training facility within 3 months. You will have full authority over curriculum and methods. The administrators left to make arrangements, remained in the observation deck with Kate. You are going to change how the Coalition teaches engineering, he said. Maybe, or maybe I'll just teach a few people to be a little more stubborn about accepting failure. You saved 40,000 lives with a rusted wrench and spare parts. That is more than stubbornness. Kate smiled. My grandfather would say it's exactly that. He used to tell me that every impossible problem is just a problem nobody's been stubborn enough to solve yet. The star in the viewport flared brightly. Its final collapse was accelerating. In a few days, it would go supernova. The station they had been on would have been vaporized in the explosion, but instead, it was empty now. Everyone had been evacuated to safety, because one human engineer had refused to accept that impossible meant the end. 3 months later, Kate stood in a training facility on a Coalition core world. 30 students faced her, representing 20 different species. They were all accomplished engineers with years of training and experience. They had come here curious about the human who had saved Station Refuge 7. The room was not what they expected. Instead of clean workstations and pristine equipment, they saw damaged machinery scattered across multiple tables. Broken power couplers, fractured plasma conduits, burned-out processors. And in the center of the main table, a collection of Earth-grade tools that looked ancient compared to the sleek equipment they were used to. Kate picked up her grandfather's wrench. She had cleaned it and repaired some of the damage, but the scorch marks remained, evidence of what it had accomplished. Today begins your training in emergency engineering, Kate announced. Everything you learned in standard training is still valid, but you're going to learn something additional. How to work when conditions are not standard, when you don't have the right tools, the right parts, or the right amount of time, when following specifications means failure because you can't meet the specifications. She held up the wrench. This is the tool I used to rebuild a StarCore drive. It's rusty. It's old. By your standards, it should have been recycled decades ago. But it worked because I understood what needed to be done and I refused to let inadequate tools stop me. A young student raised her hand. How can old tools be better than modern equipment? They're not better, but better is relative. Modern equipment is superior in ideal conditions, but ideal conditions are rare. When your advanced plasma calibrator stops working because you're in high radiation and its quantum sensors are failing, you need something that works mechanically. Something simple that doesn't require perfect conditions. Kate pointed to the broken equipment on the tables. You are going to repair these systems. You have 4 hours. You may use any of the tools available, but you may not request additional parts or equipment. What you see is what you have. The students looked at the damaged equipment with dismay. Kate could see them calculating. The repairs needed specialized components that weren't available. By standard protocols, these systems were unrepairable without proper parts. "This is impossible," one student said, a male with the confident bearing of someone used to being correct. "Impossible means you haven't thought hard enough," Kate replied. "Look at the damaged systems, really look at them. Not at what they should be, but what they are right now. Identify what's still working. Find components that can be adapted from other systems. Make connections that aren't in the manual. Improvise." She walked among the tables as the students began working. Most of them were struggling with the concept. They kept trying to find the proper way to fix each system, the authorized solution. They couldn't see past specifications to possibilities. One student caught her attention, a young female who was taking apart a communication array and examining each component individually. She wasn't following a repair checklist. She was figuring out how the system worked at a fundamental level. "What are you thinking?" Kate asked her. "The primary transmitter is destroyed, but the backup receiver has a transmission coil that might work if I modify it. The power levels are different, but if I add resistance using this damaged power regulator, I might be able to balance the load." Kate smiled. "Good, you're seeing solutions instead of just seeing problems." "But this is not how we were taught. The receiver and transmitter use different frequencies. They are not interchangeable." "They're not interchangeable if you follow design specifications. But components are just materials with properties. If the properties match what you need, the original purpose doesn't matter." The student nodded slowly and continued working. Kate moved on to other tables, offering suggestions, challenging assumptions. Some students were beginning to understand. Others were still locked into standard thinking. After 2 hours, the student who had asked about tools approached Kate. "I cannot repair this plasma conduit. The fracture is too severe. Standard procedure is to replace it." "You don't have a replacement. What else can you do?" "I could bypass the fractured section, but that would reduce power efficiency by 40%. Is 40% efficiency better than 0% efficiency?" The student paused. "Yes." "Then bypass it. Perfect is the enemy of good enough. Right now you need good enough." By the end of 4 hours, most of the students had managed some kind of repair. Not elegant solutions, not optimal efficiency, but functional systems that worked despite missing parts and inadequate tools. Kate gathered the students together for evaluation. "You all came here today as trained engineers. You knew proper procedures and correct specifications. But today you learned something else. Sometimes proper and correct are luxuries you don't have. Sometimes you need to make do with improper and incorrect because that's all that's available." She held up her wrench again. "This represents a different philosophy, Earth engineering. Humanity's home world is harsh. Equipment fails constantly. Resources are limited. We learn to be good at making things work under terrible conditions because the alternative was death. That's what I'm teaching you. Not to replace your training, but to expand it. So when the perfect solution is impossible, you can find an imperfect solution that still saves lives." A student raised his hand. "What if our improvised repairs cause problems later? What if they fail?" "They probably will fail eventually. Improvised repairs are temporary by nature. But temporary that keeps people alive until proper repairs can be made is better than giving up because you can't do it perfectly." Another student spoke up. "I was taught that safety protocols exist for absolute reasons. You removed safety protocols when you repaired the StarCore drive. How do you decide when it's acceptable to bypass safety systems?" It was a good question, an important question. Kate thought carefully about her answer. Safety protocols protect you in normal situations. But in emergencies, following safety protocols can kill you. When a station is falling into a star, the risk from bypassing safeties is less than the risk from doing nothing. You have to calculate which danger is greater, the danger from improvisation or the danger from inaction. But how do you make that calculation without time for proper analysis? Experience, intuition, best guess. It's not scientific and it's not comfortable. But sometimes you have to make decisions with incomplete information and accept the risk. The training continued for 3 months. Kate taught 30 students to think differently about engineering problems, to see partial solutions, to adapt components, to work with inadequate tools, to accept imperfection as a path to survival. Not all the students understood. Some remained locked in standard thinking, unable to let go of specifications and protocols. But others grasped the concept. They learned to look at broken systems and see possibilities instead of just seeing failure. On the final day of training, Kate gave them one last challenge. A complex repair with multiple systems damaged, time pressure, and minimal tools. The students had 3 hours. The young female who had impressed Kate on the first day completed her repair in 2 hours. She had improvised connections, adapted components from unrelated systems, and bypassed 3 safety protocols to make it work. The repair was ugly and temporary, but it functioned. "How do you feel about what you built?" Kate asked her. "It is not proper engineering. It violates 6 protocols and uses components outside their rated specifications." "But does it work?" "Yes, it works." "Then you succeeded." Kate placed her hand on the student's shoulder. "Proper engineering is what you do when you have time and resources. This is what you do when you have neither. Both are valuable, both save lives." The graduation ceremony was small. Coalition officials attended, curious about this new training program. Administrator gave a speech about innovation and adaptation, but Kate kept hers simple. "You came here as standard engineers. You leave as emergency engineers. You know how to maintain systems properly. Now you also know how to keep systems running improperly when proper maintenance is impossible. The Coalition has plenty of engineers who can work in ideal conditions. As of today, it also has 30 engineers who can work when conditions are terrible. I hope you never need these skills, but if you do, remember what you learned here. Specifications are guidelines. Tools are just metal. What saves lives is understanding, determination, and the refusal to accept that impossible means the end." She held up her grandfather's wrench one last time. "This is what saved 40,000 people, not because it was the best tool, but because it was the tool I had and I knew how to use it. That's the lesson. Work with what you have, make it enough. Save who you can." The ceremony ended. The students left to return to their postings throughout the Coalition. Kate remained in the training facility, looking at the collection of damaged equipment and simple tools. Approached her. He had been assisting with the training, learning Kate's methods, so he could help teach future classes. "Do you think they understand?" he asked. "Some of them do. Some of them will understand later when they face their first impossible situation. And some of them will never understand, but that's enough." "Why is it enough?" "Because before this training program, the Coalition had 0 engineers who thought this way. Now it has 30. That's 30 more than before. That's how change happens. Not all at once, but one person at a time." Kate picked up her wrench and cleaned it carefully. She thought about her grandfather and the lessons he had taught her. He had probably never imagined those lessons would spread across an entire galactic coalition. But that's what knowledge did. It spread from person to person, generation to generation, growing and adapting. The training facility would continue. More students would come. More emergency engineers would graduate. Eventually, this way of thinking would become standard throughout the Coalition. But it had started here with 1 human, 1 impossible repair, and 1 rusty wrench. Kate looked out the facility window at the stars beyond. Somewhere out there, stations needed engineers who could adapt. Ships needed mechanics who could improvise. Systems needed people who understood that perfect wasn't always possible, but functional was usually good enough. She smiled. Her grandfather would be proud. He had taught her that tools don't make the engineer. Understanding makes the engineer. Determination makes the engineer. The willingness to try impossible things makes the engineer. And sometimes, just sometimes, 1 engineer with a rusted wrench could change an entire galaxy's approach to solving problems. Kate hung the wrench back on her belt and headed toward the next training session. There was more work to do. There was always more work to do. But that was fine. Work meant purpose. Purpose meant meaning. And meaning was what kept you going when everything else said give up. She had learned that from a stubborn old man on Titan who refused to let fusion reactors die just because they were supposed to. Now she was teaching that lesson to a new generation. The lesson that impossible just meant nobody had been stubborn enough yet. And if there was one thing humanity was good at, it was being stubborn enough. Proper tools help, Kate said. But they're not what saves you. Understanding saves you. Determination saves you. Refusing to accept that impossible means impossible, that's what saves you. She looked at the ruined Starcore drive one more time, then headed toward the chamber door. Her hour had been up 30 minutes ago, but the job was done, and sometimes that was all that mattered. Then we will use what we have, said. Engaging Starcore drive in 10 seconds. All personnel brace for movement. Kate grabbed a support rail on the chamber wall. Did the same, his eyes fixed on the harmonizer. Through the comm, they could hear counting down. 5, 4, 3, 2, 1, engage. The harmonizer screamed to life. Wasted energy. Most engineers would try to seal the leak. Kate saw it differently. Hand me those magnetic containment rings, she said, pointing to her toolkit. What are you planning? Kate smiled. It was the same smile her grandfather used to get when he figured out how to make broken equipment run one more time. If I can't fix the leak, maybe I can steal from it. Everyone on this station knew the engineers were trying to save them. Everyone was waiting to learn if they would live or die. Kate reached the Starcore chamber and pressed her palm to the security panel. The door opened with a hiss of pressurized air. Inside, the harmonizer sat at the center of a spherical room lined with power conduits and monitoring equipment. It glowed with a faint blue light that pulsed irregularly. Kate could see the fracture even from the doorway. Dark cracks ran through the smooth surface like lightning frozen in crystal. She set down her toolkit and pulled out her grandfather's wrench. It felt solid in her hand. Real, the kind of tool that did what you told it to do without arguing about specifications or optimal conditions. Kate walked up to the harmonizer and placed her free hand on its housing. It was warm. She could feel vibrations through the metal, irregular and stuttering, like a heartbeat that couldn't find its rhythm. All right, she said quietly to the machine. Let's see what you need.